Sorry, it was fiddling around there. There we go.
Okay, cool. All right, so in that case, I'll just close the Twitch and put this here. Okay. So I think without further ado, if you're ready to start, I'll start.
I am ready.
All right, cool. So this is the complete guide to Gall, and what that means really is that we're going to be going through this, trying to poke into all aspects of it at the level that a programmer writing user space apps would do. So we won't go all the way down to the level necessarily of like how Gall is implemented under the hood, unless it's relevant for answering a given question. But other than that, pretty much everything is fair game, and any question of how does X work should be able to be answered. And if it's not, we'll ask people until we figure out the answers. So, in terms of what we're going to go through in this course in Gall 101 is 8 lessons about the sort of back-end foundation. So after doing these 8 lessons, you'll be able to write pretty much any arbitrary app, like back-end app. The thing you wouldn't maybe know is like some specific design patterns or so, that get used frequently. Um, but in terms of just how stuff works mechanically and being able to do it yourself, even if it's slightly unidiomatic, we have that. So looking through what we're going to go through, today we're going to look at setting up your entire workflow and an introduction to everything. Then the next lesson is going to be about the 10 different arms in Gall course and the structure of apps. Then we'll go through how Gall transitions you through app lifecycle and state, importing like static resources, talking to other ships, looking at data that other Gall agents have in Scry and on Peak, serving HTTP requests to the outside world along with static files, and then interacting with the outside world through JavaScript channels. I've said later here that JavaScript is a requirement. That's only the case if you're writing front ends. Like even in for this last lesson of the backend with JSON and channel.js, you barely need to know JavaScript in order to do it. So Hoon is the only real requirement for writing Gall backend apps. So, what is Gall? It's a typoed program, which is an OS kernel. And essentially, what it is a program that manages Urbit's apps. Okay? So you have Arvo has these kernels that manage things like networking, how packets get in and out, um, like version controlled files in Clay, things like this. Calls out on HTTP with Iris. And Gall is just sort of that module that handles all of the apps that are installed on your Urbit. Okay. Now, the one thing here to get really clear, and this will become clear, I think, later, probably around the time once we get to the maybe the poke lesson, but especially the scry and on peak lesson, it'll start to become very clear that Gall apps are pretty different than what you normally think of as applications. Like, what you traditionally have as like a SaaS app in the cloud, or the applications you used to buy for like Windows or Mac that are in like a big package and you put on. Um, Gall is much closer to a platform that not only manages each app in the way a traditional operating system does, but it also manages the interactions between those apps and the upgrade paths of like all of those apps working together. So I gave a little link here when I under cleanly interact to like an interesting article on this idea, unurbit related. Actually, interestingly, the author, this is from about 5 years ago, was critical of Urbit. But since that time, Gall has really taken on this idea that your applications can be autistic, but they don't have to be. So autistic in this case, meaning they just live in their own little world and do their thing and interact with other applications with extreme difficulty. And Gall is the exact opposite of that. It makes it extremely clean and fairly easy to interact with both apps that are on your local Urbit and remote ones with a minimum of friction. So the kind of things you're able to do with it are you can run background jobs that periodically check data on your machine or another machine, and it's much easier to set those up than in Unix. You can coordinate data sources from multiple other Gall apps. For example, you could figure out like, what groups you know about, which ones you're an admin in, what the entire chat log is of any chats in those groups, see what the metadata is for those. All of this data is stored in other Gall agents, and you can query it. You can provide full-blown user experiences with a front end. I don't really have to justify that since we, literally have it up right now in the right side of the screen. This is, a full JavaScript app that's interacting with the chat store app on the back end, and some also the group app and a few others. And you can run database resources that back multiple services. And so that's another thing that I think everyone who uses Urbit frequently is super familiar with. They're really familiar with this, like, we have groups, links, chats, all of this stuff kind of like interacting together and more or less working decently seamlessly. Okay? And what Gall handles is all of the messages going into your app and all of the messages going out from it. So messages are any command either from you, like to your own app, or from another app, or like, part of the operating system to you, to your Gall app, or you sending out messages to other parts of your operating system or to other Urbits, to other ships. Okay, and so Gall handles all of that and kind of packages those incoming and outgoing messages in a very standardized format and routes them to very specific parts of your Gall application.
Can I ask you a question about that part?
Yes.
So Gall being the vein handles all messages going between ships or sort of around the operating system environment and routes them to the correct application that is like a Gall subset or other vein if that's the
Yes.
case. Okay, all right.
Let's go down here and like even I actually should have put another thing in this diagram, which is like other ships, but I think it handles it. Let's say we have our Gall app that we're writing, and it'll look, something like what I have on the screen right now over here.
Okay.
When I say all these blue lines right here, on init, on save, on load, on poke, those are all different arms of the main Gall core. Okay. And you've probably seen this before. So that's what we mean when we say our Gall app. And when we say that Gall handles all data to and from our app, what we mean is that if, like, for example, Air gets an incoming HTTP request, it sends it to Gall in some format that Gall said it expects those messages in. And then Gall both translates it into a certain, data structure when it sends it to us. Rabsef, you need to be louder relative to
Oh,
me.
thank you.
So what Rabsef was asking about, just to clarify right here, is sort of where Gall sits in this relative to other ships and the other veins in the operating system. So I was saying, Air sends in a message structured in a certain way. Gall takes it, puts it into a new structure, and Gall also is responsible for knowing about what arms our app is required to have, and it's actually going to send that, like, incoming error message to a very specific place. In fact, what it does is it turns it into what's called like a poke message and calls this on poke arm with a certain data format. And we'll see later in our lessons how to, like, unwrap that. But the key thing is that Gall acts as this buffer that makes sure we always get that message in a predictable way. Conversely, Gall also defines outgoing data structures, both for all the other parts of Arvo on our local Urbit and for sending information to other Gall apps. Okay, so the part I don't have in this diagram is that I really should have an outgoing arrow from Gall, like even like outside our box here to the box of another Urbit ship. Okay, and we would actually send it over to there into its Arvo, where it would end up in Gall and then get handled, like sent to like the agent we had requested over there. Does that make sense?
Yeah, last question on that. Then
Mm-hmm.
the interaction between two ships is not through air or any other method. It's like Gall to Gall. Then is that right? Or Gall
That's
to
correct.
ship?
Yeah. So
Okay.
what? Yes, that is absolutely correct, and it mediates those. I actually need to think so I don't say anything wrong, but if it's possible to call other ships in a different way, it's at least bad practice to do so.
Okay.
You probably could set up something super hacky with air and kind of like like jank it into there, like communicate air to air, I guess iris to air or something like that. You probably could do that, but for all practical purposes and best practices, yeah, you'll be sending data to other like Gall agents on other ships.
Okay.
Okay, and that gives us a huge advantage if you've ever done any kind of network programming at any level, which is that we can make a lot more guarantees about the strong typing of messages going into these apps, right? Like when you call that other app, it can like publish some definitions of what types it expects to come in, and as long as you send stuff that matches those types, the other app is going to be able to handle it and validate it like much more easily. So
Okay.
a lot of stuff related to like serialization and deserialization, that's like a huge annoying part of like network programming, um, like Gall handles in really clean ways to the point where you're not as afraid of doing asynchronous like apps that like require stuff across a network than you would be otherwise.
Okay. Cool.
So it's pretty cool when we get to that and calling other agents. And in today's workflow lesson, I'm going to show you how you can set that up to test. Okay.
Nice.
And yeah, Rizuk says he likes the idea of Gall being a post office secretary receiving notes, directions, and orders and passing out the same. Yeah, and I think we can like take that analogy even a little bit farther, where the secretary is like, in the old office model was like the buffer between the boss and the outside world, and Gall very much acts as like the buffer between all of this data sitting on an Urbit and the other like Arvo veins, and other ships, and even other Arvo like Gall agents on the same ship talking to each other. Okay, so they'll talk to each other through Gall, and ships will talk to each other through that. So it's definitely like a very big choke point within the Urbit world where like the magic happens to a large degree. Okay, so that's what we mean when we say, and that I think is a great way to when we say platforms, not just applications. I would highly recommend reading this article that I linked here. Just it's like fun, and like in terms of what he's the world he's imagining. One of the cool things is at the time the article was written, this didn't exist, and now it does, and a lot of things that people have thought would be really cool are now doable today. Um, so let's talk about Gall's responsibilities, which we've already hinted at, because it's not just the secretary function and like getting data straight. Okay.
All right.
One big one it has is app registration. So we're going to do a command today in a little bit where we tell Gall to start listening, or basically to start watching a certain piece of source code. Okay. And if we look, for example, I'm just going to open up in like a fake, or actually it's it might be, yeah, I can do it like Urbit Zod home. If you look in like the app directory, which you see here down at the bottom of a like fake Zod I have up, we see all these like .hoon files in the app. These are all Gall agents, and they're all registered in Gall. What that means is that anytime there's source code with that name, so if like group store is registered, anytime group store source code is updated, Gall will go through a specific procedure for recompiling that, and making like upgrading it if necessary to keep it consistent. So that goes under compilation. Upgrades, if your app will have state, like for example, just in this little toy app here, we have a counter that's an atom. And if we like, let's say we later decided we wanted that to be a tape or a different kind of number. What Gall does is every time it compiles, it gives you a way to save the old state and then load that state into the new version of your program so that you could potentially have a predictable, clean way to change the type of this without breaking everything. And that logic can actually get pretty complicated. And I'm not going to go into detail of like what it's doing, but for example, if we look at app like group store, I'm pretty sure this will bear out what I want. Yeah. So I think everyone remembers the like recent like whole groups refactor sort of fiasco. And actually that was because they were making a massive change to the type of state stored in here. They were going from the state 0 to state 1. And the easy way to say that is if you look at on load is the Gall arm that's responsible for handling these transitions from one type of state to like maybe a new version, essentially a new database schema. And if you actually look at how long this on load function is, it's like it's not so long. Let's see, let's line 159, but like this is a 80-ish, 80, 90 line function to handle the transition from one to another with all of the attendant, like, possible logic problems that can happen along the way there and unpredictable things. And so one big issue with the groups refactor is they just like tried to do probably too much at once. And that was part of like the post-mortem there is that you can do these massive state migrations with Gall. It's generally better to like kind of chop them up and keep them as small as possible, while getting some new functionality and then making sure that works, because you can run into these like pretty big issues. So just it's just worth noting that they were able in principle to do that sort of huge upgrade of how everything worked and sort of in theory have it all work, although that is fairly hard to get right. We already talked about requests between the Gall app and Arvo veins, um, and then requests between Gall apps themselves and requests between Urbit ships. So basically, anytime you want to talk to something else, whether it's Arvo, other agents on your system, or other Urbit ships, you're likely to be doing this through a Gall app. Any questions there?
One, when we say source code changes, is that not
Mm-hmm.
just the Hoon file that's in the app folder to begin with, or is
Uh,
there different source
okay.
code that we're talking about?
No, we're just talking about this is actually one great thing about sort of the Urbit model and especially the Gall model here, but there's Urbit in general. All we're talking about is the source code that's in the app directory.
Okay, so anytime
And
that
then by
changes, Gall also handles applying that to like the running agent that exists
Yes,
in.
in
Okay,
fact, we're going to get to this a little bit today in workflow and then more in the app lifecycle lesson, which is the next one in a couple days. But basically, what happens is, just for a quick mental model, it sees the code has changed, it recompiles it, it runs a thing that we'll look at again in that next lesson to transition any state if necessary using the on save and on load functions in case the state type has changed. And then if that all succeeds, now that new version of source code is the one that's running on your ship.
okay,
And we're going to see in about probably I think 5 minutes like a concrete example of that where you actually sort of get to do it. Okay, so you can
cool.
kind of see how that works. So the last part here is just Gall versus generators, because I sometimes get the question of like, oh, we spent all this time learning generators in Hoon.
That's
Why
because the
now we're
only
just
thing I know
doing
how
the
to do is a generator, so that's what they got.
ironically, like I'm like kind of bad at generators, like don't write them that much, and I like do everything with Gall apps, even when I probably could do it with a generator.
Nice.
Um, so so generators, you already know, they're used to process data. They take some input and return a value. They're very similar to like kind of pure functions, although maybe they like call out to the outside world using one of those veins. Um, Gall apps are when you want a longer running persistent service, something more like a daemon in typo a Unix, right? So like something that's like just always running in the background and listening for messages or periodically performing tasks.
Okay.
Okay, so handling HTTP requests coming in like a web server. So for example, everything with the chat view and app and the chat store app. The chat view app is just constantly running on your Urbit, waiting for new requests to come in from the JavaScript front end so it can process them. Okay, so that's just like kind of HTTP handling. Work with the OS. Maybe you like want to periodically set timers. So I have my program that I run for my groups like Backy, which is kind of like a hacky program that just literally sets a timer with Arvo, and every time that timer dings, it writes the current members of the group to disk so that I don't get screwed if like I have to breach, which now we're at like since about I think late April and still breach free. So
That's
there
a
might be
cool
times where you'll
idea,
lose
man.
soon.
I like that.
Yeah, so that's like some of the groups that that I run that people are in. I feel a lot better now and less worried about breaching because I know I won't just like lose all of our members.
Plus, you can find
Um,
interlopers, right? You can see if
Yeah,
somebody.
you can do a lot of. Well, my groups are all closed, but
Okay.
we're going to get to actually something in a second on exactly those lines. So you sort of anticipated it. Long-running applications on your ship. This is again similar to maybe like a database store or something like that, or like the group store or the chat store that just run in the background, storing each accumulated change to the groups it knows about and the chats that it knows
So I
about.
guess that's really interesting because I don't know that I realized that chat store wasn't what was being called by like the Java. So there's like another Gall application, this chat view that kind of pushes the needed lines from chat store to the JavaScript that's displaying it on the screen on your right hand side when
Mm-hmm.
necessary. Is that right?
Yeah, like more or less. That's close enough to pretty much be accurate. Like
That's cool.
yeah, and that's because like Gall, they're not Gall apps aren't quite apps in the way we think of. They're like they live more at this like they can be like just full autistic applications, or they can be like more or less something more like Unix services
Hmm.
or cron jobs. They really like or actually a lot of the time a lot of these apps like are getting much closer to like being like SQL databases, but integrated directly into the app.
And
So
that's
they
kind
really
of the
anything that
direction they're
involves.
going, right? Like having multiple different like the chat, the store, and
Hmm.
I can't think of the other names from, but
Well,
the
so that exactly the direction they're thinking of going is having this generalized agent in the graph store
yeah, okay,
that stores all kinds of social data, whether it's like links or like posts or a Twitter thing, and then you basically make your view app on top of that, which says, okay, I'm gonna like mediate these interactions with the store as stuff comes in from the front end,
okay, cool.
right? I think and in Gall kind of 201 or two, I forget how university is supposed to number these, whatever, 201 or 202, whatever it ends up being. I'm going to go over that model, the kind of store hook view.
Okay.
Yeah, Taduk, that's a really good question. Currently, you cannot turn off a Gall app. I need to like just quickly check what happens if I like delete its source code. I think like I'd be actually, you know what? We can even like just try that real quick. So if I have like right now a thing like running in the background, and we're going to look at this app in a second. I just like the question enough that I want to look at it. Okay, so I have that, and then I'm just going to go ahead and delete the file. Um, let's go up to Zod home app workflow. Okay, so, so we did that. It should no longer have it. Now let's like commit the change. And yeah, so what it goes here, Taduk, is it says like the workflow scribe failed. Basically, it asked Clay, the revision control system, to find workflow and said it couldn't. And what it actually does there, that's actually interesting behavior. Yeah, it actually just keeps the code. And because that sort of failed, because it's a revision control system, it just doesn't like move you to the next version and basically just doesn't do it. I think they might add some ability to uninstall stuff at some point. And in my opinion, they like definitely should for a variety of reasons. But there might be some good reasons not to that I haven't thought of.
Yeah, like just reinforcing not making mistakes, right? That's
Exactly. In
all you need.
America, you reward excellence. In Japan, we punish ignorance. Um, yeah. So now, fortunately, Taduk, there are ways to like I guess the other thing you could do is you could upgrade what your app does to like be basically nothing. So you could have this like upgrade path for your app that says in our next version we're just going to like lobotomize it and delete everything in the store and all this stuff. So in practice, that would be like one way to do it, and just maybe make a message there for users like stop using me. I'm no longer like cool or supported. Um, so that goes for okay. So think of Gall apps as like anything where you want for some reason like a long-lived service to run and generally mediate some state. Generally, the state part, the long-lived part, definitely. The state part, almost all the time. Um, Over the course, like Rabsef asked, can you? How would I say this? Um, can you monitor your groups through Gall?
Mm.
Having one agent maybe query the chat store. The answer is A, absolutely yes, and B, throughout the course of this course, we're going to create a real application that lets you monitor all the users in chats that you're an owner or admin of, see all the messages they've posted recently, and add up like their activity in the last week or month or any time period that you want. Okay. And what that's going to let us do is explore all of the well, A, it's going to give you guys something challenging to do, but also it's going to let us explore all the different aspects of things that Gall can do, because nearly all of those have to be done in order to do this. I would say like basically all of them.
That's really
Okay.
cool. I'm excited about that because I think one of the most difficult parts for me is not making monolithic applications because I just have that context for how applications work, you know? So seeing something that will
Mm-hmm.
allow us to talk to some of those other database like instances will be very cool.
Yeah, for reference, I have like a full version of like the back end part of that working, and it's not tiny by any means, but it's 300-ish odd lines, which is, and like a lot of them are like, I would say like all the lines through about here are like the first like 150 are like fairly like really straightforward, and like you can just look at it what's going on, and the actual kind of tricky logic is isolated to like a very few parts of it. So that's like a pretty good indicator of like what happens when you start making like one of these multiple, integrating multiple data sources Gall apps. It usually ends up in that like kind of 150 to 300 line range. It's pretty, with a lot of that being stuff that you kind of know where to look for each thing because it's in some predictable arms.
Cool.
Uh, okay. Anything else there? Or should we move on?
Let's go.
All right, so now we are going to go to our essentially our lesson for today, which is about workflow setup. And that sounds a little basic, but it's different enough maybe than what people are doing with generators and Hoon that I want to show what's happening and start to give a little bit of a feel. So, um, the first thing I'll assume is that you know how to make fake ZODs and use like mount and commit. Is that accurate?
Mostly.
Okay. um, just like, I mean, if we want to like brush it up real quick, like essentially it would just, I'm not going to do it right now because it would take a while, but basically it would just be urbitf zod or bus or timluc or whatever name you want to use, and that'll make one.
For sure.
And then I also, I'll show a little bit later in a second, I definitely kind of keep like a backed up copy of one of those once it's made. So usually I'll make the fake zod, then inside it I'll run like mount and maybe even like a commit, just so that those commands are always there the next time I go back to them.
Got a question about that. Do you ever find yourself saving another copy of your fake sod during development when you get something like mostly working, and then you're gonna test something that you think might screw it up?
That's a good question. So you're yeah, good. So you're saying maybe I have some like I'm in some data state and I
Yeah.
don't want to screw it up. Yeah. Um Answer A, absolutely. Answer B, the situation. Hmm. So yes, often what I'll do for that is use like what's called like an L ship, and I'll show that in a second. But basically, what I'll do is I'll take like um like for example, I could even take like timluc-miptev or another one I have,
Hmm.
and just make a backup copy of it and then run it with the L parameter so that I can just get access to everything there. And in fact, that's going to be an exercise at the end of this lesson, is going to be to take like one of your, either you could just use your real ship or like a secondary ship you have, but a real one that has certain data on it that I'll specify, and just make sure you're fine making L ships of that. And the reason is that if we want to seed chat data and group data for the purposes of making our chat admin app, it's nice just to have like real stuff to work with without having to like seed it.
That's a cool idea. I hadn't thought about that. Nice.
Yeah, so I did that. Actually, so what I did when I was doing the development of this app is this chat admin app, is I took my secondary so I took my secondary ship, I added it to like my group, the collapse, as and I added it as an admin, and then I took that ship and like made a like sort of fake or like non-networked version of it, which I'll show in a bit, so that I could use it and have all that data in there for development and practice stuff like deleting users and things like that.
Nice.
So that was like, and I could use timluc-miptev for that for sure. I just really want to minimum. There is a mild risk of a breach if I mess something up there, and I just don't want that. So that's, but it's not like depend, like your mileage may vary for how much you care about that small risk. Um,
So at this point, should we
okay.
understand the example code that you have here, or we're just putting it in?
So the second sentence
Oh,
is you
yeah,
don't
okay.
need to understand it
Sorry.
yet. It's you are taking this and just putting it in. And what we're gonna do is we have this example code right here. We're gonna take it and we're just gonna go and we're gonna set up. So, do you have like a fake Zod up or one you can use?
I do. I'm wondering how I'm going to do the screen layout in this case. I think we can figure this out. Let me bear with me for one
Which
second.
aspect of the screen layout? Because I'm not looking at you.
Well, I just don't want to lay my. I have to do full screen
I see.
sharing to make this thing work because it gets
Okay. Well, why
complainy.
don't all right, what I'm gonna do then is I'm just gonna go ahead and make it. So,
Okay,
real quick, just a
let's do
couple
that.
things to look at that I often do. This is like such a common pattern that I'm just gonna like show it. Something like this. I'll put it in the chat over here. And this is like the kind of thing I do once I've made my backup ship, which I'll look at in a
Hmm.
sec. My backup fake ship is I have it in this thing here, back 01, meaning that's the version of Urbit, like the OTA code. Um, I'll just like remove the current Zod directory. I'll copy this like back 138 to Zod and then run Urbit Zod. And so I usually just my usual workflow. Someone probably has like a sexier version of this, but it's literally just like I have that go like on one screen over here, and so I'll set it up, and that's about my time to go up. And then over here I have the Gall guide, and in fact I already had in the Gall guide. I'll just open it up and we'll go ahead and make it right now. Ducks Gall guide example code at workflow. Okay, I'll just go ahead and delete this for now so you can see it everything like being done for real. Um, okay. Um, so we're gonna go ahead and paste this code from up here, and I will explain it slightly because you don't have to understand it, but it's nice to like roughly understand what's going on. Okay, so here's the code. I could indent it perfectly, but not gonna bother right now. So that's sitting right now in my example code app directory. And what I need to do now is I need to get it into my peer. So up here, I have like I just do copy example code app workflow.hoon to Urbit Zod home app. Okay,
Got it.
which is the one on there that's already mounted because as I said, I make when I before I save like my backup here, I usually run mount and commit in it. So you can actually see here I have those I have like commit in the history.
Makes sense.
So we'll go ahead and these are all just like little things that help it day. So it's up right there. We then said so to install a new program in Gall, you make sure the code is there, and then you tell Gall its name with the start command, and Gall will look for a Hoon file with that name in the app directory. So we just ran commit home, and it tells us right here that it knows about workflow Hoon now. So now we're going to run bar start and then send workflow. Okay. We see some messages and we'll see a couple little tricks here. We see this on init printed out. Crucially, we don't see any errors. Okay, so that means that if we don't see any errors once we run start, it means that our app is working in the background. Okay,
Okay.
and I'll show you in a bit how debugging works. But I have debugging set up for this app, which means I can type the app's call the app's name plus debug, and it shows me prints out its current state. Okay, we'll see exactly how to set all that up. But the key thing is, I know it's working because I didn't get any errors, and I now have access to I can kind of do stuff to it. I can kind of poke at it in various ways. So let's look at the the actual app real quick. At the top, we have an import, and we'll learn about imports a couple lessons from now and how to use them exactly. The main thing to know is that there's a directory by convention that holds kind of like library code and another that holds type code. And you import usually from one or both of those for each app. So this like fast lus is from the directory that holds library code. So we just import a couple libraries. Then this you'll see at the top of basically all Gall apps. And what it is before you start writing your app, you make a core that holds all of your types. Okay?
Okay.
You generally don't put logic in this like core because people will usually make a core later that has logic. And the reason for that is that core needs to have access to some like information Gall gives about the current state, like the current time, our ship's name, the source of an action, stuff like that. Okay?
Okay.
But types don't depend on that. So it's safe and best practice to put a core at the top that has some type information. So what I do here, oh, sorry, go.
Why do we need version state with a type of state 0 and then also a definition of state 0? Could we not just have...
Let's just say, just make our type state 0 and be
Yeah.
done with it. Yeah, absolutely. Oh, you know what? I still have the old version in here. That's interesting. I should. Okay, good. I fixed that in there. Okay. Oh, that's in here too. So it doesn't affect our code for these purposes, but I want to. This should be a 0 and not a 1, just for consistency. Okay. The answer is that you absolutely could just do state 0 as your type. Okay.
Okay.
The problem then comes if once you have like, you know, multiple versions of your app out in the wild and you need to have an upgrade path. So let's say you start with state 0 and then later on something about this changes. Like let's say I just want to change this thing to a tape or something, right?
Right.
If I go ahead now and actually try to like, doing live coding, so that never ends well, but okay, so what I did is I changed this in my directory. Now I'm going to copy it. Great, I got an error, which is what we hope for expected. And the reason we got an error here is it gets a nest fail. Basically, like we just went and messed this thing up and got into like an inconsistent state because it had counter as an atom, and now it tries to like upgrade to this new version of the app where it's a tape, and it has no way to do that, and so that produces an error.
Okay. Okay.
Does that make sense?
Yes.
So that's like kind of by way. I'm actually just gonna like restart our app real quick. Good. That's by way of saying that. Let me make sure there's no questions in here. Okay. At that point, you'd be like, oh crap, I need to have a new version of my app where counter is a tape. And what you would do then, and we'll see this in like literally the next lesson, is you would make a new type called state 1. It would look something like, again, live coding, but I won't do it all out right now, but it would look something maybe like this.
And then you'd have some logic somewhere else.
And have some logic to like basically like I actually we can even imagine like what that logic would look like. I won't like Socratic it, but like the way it would look is maybe one rational way to handle that is I would turn my atom into the tape representation of that number.
Mm-hmm, mm-hmm.
Right? And then I would just like I would transition that. Okay? So that's the answer. So basically what we need is where that comes into play is that if I looked at like a bigger app, like something we were looking at earlier, like Group Store, we'll see they actually have this exact pattern at the top right here. And they go ahead, and it happens in the onload function. So onload basically does this thing. It gets a vase in, which is dynamic data. It says this dynamic data better be something of version state, and it extracts it. And then it starts doing all these conditional statements and branching based on exactly which version that is, if it's version 1 or the old version.
Oh, that's cute. So literally that demarcation at the beginning of the state, like the send 0, that's just a tip off as to what state you might be in. Is that right?
Yes. In fact, it's even more than a tip off. It's like you would actually write your logic to switch on the head of this like data data structure. Cool. Right? So it's a tagged union, and you would just switch on the head of that tagged union.
Okay.
Now, this is all by convention. There's like nothing about Gall that like really mandates this, but this is just such a strong convention that you should pretty much assume every app will have this. And if it doesn't, like that's you know, Salon should rewrite it or whoever wrote it.
Okay.
Like it's like because you're just like you're being, yeah, you're being objectionable for like no good reason
Okay.
at that point and just making stuff hard for people. So yeah, it's not programmatically enforced. It's a convention, but it's an extremely strong one. I think it's in almost all programs in Gall. So we have all that there. We finish up that core, which just serves to like lay out some types, and some of our other apps there'll be a couple more types in there. Um, we do this thing which you don't have to understand yet, which is I call the gate agent debug on everything below here. Okay.
Hmm.
And it basically wraps it up in something that allows us to do this command. That basically it basically says keep the app exactly the same as before, except it also knows how to process this lust debug command, and it knows to like go ahead and like print the state at that point.
Okay.
That's not as hard to do as it looks to do those kind of wrappers. And later on, we're actually going to learn how to make like those kind of wrappers, or also how to use other people's. Okay, because it's actually a pretty common thing to be like to define these. Okay, so that's everything. After that's all of the preamble, and then the actual basically program starts, which is we go ahead, we pin a variable to the front of type like a bunt value of state 0. This is you could write this in a lot of ways. I also could have just as easily written state equals state 0 and then not do this, like this line,
Okay.
right? And this just I don't even know. Honestly, I just started doing this because I see it in so many of the programs. I don't think there was a good. I remember Palfin talking about it once, and I don't think there was a good reason for it.
It's
But
slightly more confusing, so that helps them maintain their control, their death grip on the
exactly,
system. Yeah. Okay.
I guess like for me, it was like I just want to make sure I like understand everything, so I used like the weirder one. All it does here, I mean, like tislus is a macro. So the macro just says every time you see the word state, it should mean whatever the head of the current subject was right here,
Hmm. And that
which
would
is the
be
variable,
right.
the thing we literally just pinned.
Okay.
Okay. I also have in a lot of my other programs though just used state equals state 0, or even you can do state equals version state. I do prefer now to have your state be the type of variable, or sorry, be the type that you actually want to use, and not just version state as a whole, because it basically says that once Gall finishes the upgrade logic, it better be in this form, not any version state form.
Okay. Okay.
Does that like so just to be clear? I should actually get an example of one where I haven't done that yet. Um, let's just like look at this. Probably doesn't have that. Yeah. So for this one, I did instead of state 0, I just did tisbar state equals version state. The problem then is my state can technically be any of the version state types.
And then you don't know if your upgrade succeeded if you start having more than one.
I mean, your upgrade, yeah, or you don't like force it to be the case
Okay.
that your upgrade must succeed to do it. So that's bad practice, and I actually have a note in my to dos to go and fix all of those to essentially this format,
Okay.
so that we basically are declaring that we want to be in that. Okay. Next thing up is we've basically set up our core with those types. We've pinned a variable state with the name state to the front. We cast the next thing to Agent Gall. So quickly here, while we're talking about workflow, we might as well just explore kind of everything. Um, what we're going to explore now is zoos. So do you know? Are you familiar with like zoos.hoon?
Yeah.
Okay, so this is like basically the interfaces for everything in Arvo. Okay, so it's included by default with every file. Every file has this as part of its subject. So when we type like call Gall, it knows what that is.
Hmm.
So here's the Gall arm, which evaluates to this, and it goes and looks for. We're saying to cast it to type agent in that. So if we look for agent, um, okay, agent app core. So we have like the app core, like the app core agent. I think there's also I thought there was also like a type agent in here. Am I going?
Is it that one under neat?
Let me see where there's if I can find like agent because no, it's just that one in there. Wait one sec. Okay, so it's just that arm agent. So this is Agent Gall. The agent core. I'm trying to so this one I have to. Oh, I know why it is. Yeah. Okay, because it basically does the Tisgal, and it says evaluate form in light of this core. So basically, form is one of the arms of this whole core, and it evaluates it, and form is a type declaration,
Okay. Okay.
right? With the buck cab. That's why. So essentially, the thing it produces is form, which is a type declaration.
What's the cat
So
bar doing there?
yeah,
I don't
we're
know
gonna go
cat
into
bar.
that.
Okay.
That's in the next lesson. What that is cast the core below as an iron core,
Oh, okay.
essentially, which essentially means don't pay attention to its context, just like the its arms and what they take.
Okay.
Okay, and what they take and what they produce. That's what it means. So we'll look at that in the next one because it's really important. And this line here is essentially how Gall is able to guarantee that everything going in, all its agents have exactly 10 arms with exactly the names that it expects.
Oh, cool. Okay. Cool.
So it's super relevant. And that's our next lesson in the 10 arms of Gall.
I like
Okay.
that.
But all you need to know for now is that we can follow this if doing this this cast, and what it's casting it to is a very specific set of arms.
Got it.
Declare and just showing people kind of how to find them, I think, is important because it is good to know like the stuff isn't magic and that it's coming exactly from here and we can analyze it. It's actually not even like very much code at all. Like we're talking like 40-ish lines, odd lines of code. Next, we have a door, and well, now we know this everything under this is of this type, which is a door, and so then we go ahead and basically define that door in the same format. Okay,
Okay.
and that's pretty much all we need to know for here. Now, since this is a workflow lesson, we're going to go back to workflow now, which is you were asking how does Gall recompile and how does that flow work?
Mhm.
So we have our thing right here in our example code directory. I'm just gonna, you know what, this is bothering me. I'm gonna change the indentation. Okay.
Oh, it's
Um,
so much better now. Thank you.
yeah. um, so all we're gonna do right now is instead of saying on load, we're gonna change this message to be like workflow loaded. Okay.
Okay.
And we'll talk about the on. We actually will. We're gonna talk about the onload function more in a couple lessons, but I want to do just briefly mentioning here. So we do that. We go over here. We copy it. I'm sure some like clever person watching this will like just write a watch script that either like waits or checks for changes in the directory and does this exact copy to the peer. And that's great. That's like a better way to do it unambiguously. I'm just like lazy. So we
I don't know
commit. So we
about
commit
lazy,
that.
but okay.
We commit home. Now we see it shows workflow loaded. So what just happened?
It
Okay.
recognize. Oh yeah, go ahead.
No,
I thought you were
talk.
asking.
I am.
it,
I am.
okay, it recognized that you had changed that onload function, so somehow that was uptaked into the Urbit environment, and then it kind of reran the program, which on loading of itself, it does that debug print.
Yes. And we'll do this in if we go to if we look at so we're coming from our overview. I'll just quickly go here. In 2 lessons from now, we have app lifecycle and state, which is everything with the on load and on save function, and we'll look at exactly how that works. The 90% version of it is that it recompiles and makes sure that it validly recompiles. It then goes ahead and runs on save to yank the current state and throw it into a vase in this line right here in line 21.
Okay.
Then and it does that and critically, it does that in the old version of the agent. Okay, so it compiles this first, but it doesn't replace the old one with it yet.
Right.
It runs this function to package the old state into a vase, and then it passes that vase to onload and runs onload in the new one. and then
Okay.
everything just and then it at that time it replaces our old version of workflow with the newly compiled one. In this case, in onload, we actually just ignore that incoming vase and don't do anything with it because we don't change anything here. And all we do is the debug print here of just saying workflow loaded.
But that's where we would have our state change logic if we had a state change in the works.
Correct. And just
Okay.
like, because it's good to see like actual quick, just very quick examples. In a real version, like on load is a function, is a
Right.
gate that expects it's something of type vase, right? So we do this old equals vase, and then we go ahead and yank it out of there.
Cool.
Okay, so and actually, really quick, what we did here is we defined, this is actually something I think I should just go over quickly in this, like in this lesson, what's happening in this lustar line. Lustar is basically just a macro. It just inserts kind of code at the top of each arm in a similar way to like tistar.
Okay.
And so what we say is this is just the current subject. Okay, so we're basically just going to get the, which in this case is like, our current door that we're inside.
Right.
So there's a lot of right, and so we use that in a couple places where we want to return just to the agent itself. And we'll look at this in later lessons. The key thing is just that people might not have seen that I want to talk about because it's so common and is in every program, is just this syntax right here. Okay, which is the basically running an arm in a door with a value. Okay.
Okay.
But notice that I think you probably are used to like things like, you would have like put by my map and something like that, right?
Yeah, yeah, yeah.
Like all this stuff. And you're used to this first thing being the name of an arm in the door, right?
Sure, yeah.
Like tap or put. And so this threw me a bit when I was first doing Gall. And the answer is that it's really more of a syntactic thing than anything to analyze. But all it does is, as usual, the second argument is the door in question. The third argument is the argument to the door. And instead of like calling a specific arm when you do dot, it just basically gives you a version of that door where the argument is set.
So
So
then
all of
later
so
you could do it.
exactly. So essentially, what we do then is we evaluate all of these arms of the door, like with the door as the subject in all these lines, and they all have bool set to the proper value.
Okay. Okay. I
Okay,
follow that.
I can give a like I think it's just one cool thing about Gall and just Hoon programming in general is how much you can just like literally go to the source. So we were importing this file default agent, and default agent literally just like it's a door. Um, oh, sorry, it's a well, what default agent is it's a gate that produces a door.
Oh, okay.
Uh, Okay, so it takes agent as a noun, help as a noun. So we say the agent in question is like our agent, and help is the no value.
Oh, that's what that's supposed to be. Okay.
Yeah, I mean, honestly, this is one of those things that I just do what everyone else does, but I literally just easily could write no, and I'm like 94% sure that's gonna like compile. Yeah, honestly, I should really write
What is
this.
the node?
Um,
Oh, the help just
is
determines
the
whether or
help
not it.
argument?
Okay.
Yeah, exactly. Like if it's gonna produce some extra stack
Right.
traces and stuff
Okay.
like that, right? And people often just set that to no because they don't care so much about like default, like the crash there. Um, and then what it does, that produces a door, like this, like running this default agent gate
Mm-hmm.
produces a door, and so that's our second argument, which is like this door here, which expects a bool sample.
Okay. And it
So
produces that door based on the configuration elements that we gave to the gate.
yeah, exactly,
Okay.
exactly. So the gate, yeah, exactly. And so the gate basically has some extra stuff in there, and then it produces the door with that stuff in the context,
Got it.
in its context. Okay, so pretty straightforward stuff there. This is in pretty much all programs. It's either called like def or default. We'll see the same thing here. Here it's called def. Exactly the same code here,
Mm-hmm.
and this is just over and over again. And all it is for a lot of these, we need to like supply some implementation, because if we go back to zoos, and like it requires the thing returned to have these 10 arms, but a lot of the time we don't care about implementing all of the arms. Like all I wanted to do here was implement on save, on load, on init to kind of show how those work, and I didn't need to implement the others.
Okay.
And for a lot of apps, you don't end up needing to implement all of the arms. And so I can probably find, yeah. So here they didn't need to for group store, they didn't need to implement on agent, on Nervo, on fail, so they don't, and they just use the default version.
Cool.
Okay, and what the default version usually does is either nothing, or in some cases, it throws errors if like Gall tries to call it.
Okay.
Okay, so like a good example of that is if you there's a few of these arms that if you like try to call out to air and have it serve to some HTTP endpoint, you have to have them defined, otherwise it'll throw an error when when Gall tries to call those arms, because error sent back a message.
Okay.
Okay, we'll see those. It's in general, it's pretty clear, and like on default, like the default function will throw an error that like, hey, I got this message back I wasn't expecting, and then you just go ahead and implement that arm.
Okay.
Okay, so that's in terms of workflow, that's what we're expecting. We'll just a lot of this is like the thing that we've seen a lot now so far is just me making changes, copying them in, recommitting, and then it loads. Or I mean, I guess I could break it really quick if I want. And just show it not loading anymore. So I change that rune to something, and it says I don't like this anymore. The
Nice.
other workflow thing here that you'll see a lot is this. Are you familiar with SIGPAM
Yeah.
and with these things? Okay, cool. And then I just randomly I choose like either if I want it to be for my ones that are like saying that it loaded or on a init, I usually use one gar to make them green, and then the others I usually use two to make them yellow or three to make them red.
That part I was not
Um,
familiar with until Rizrak
that,
explained it to me recently. That's pretty cool.
Yeah, we'll see that a lot. Interestingly, with Urbit King, the color printing is gone, so that doesn't work anymore. But I do most of my development with regular Urbit, not Urbit King, because I don't think Urbit King, or maybe it doesn't. I'm missing it, but I didn't see it had like the L parameter.
Okay.
Um, okay, so now we go to quickly to debug. Um, this is this thing where we said we wrapped it up in something that lets us examine the state.
Hmm.
The only thing, the way it determines what the state is it actually debug actually calls your on save arm.
Is that all it's doing?
Yeah, it's just call. It does. It has some other options. Like there's other. Let me find my scratch pad. So if I go to okay, so I can do stuff like the following. So we'll just do this workflow. So workflow debug, this just all it does is calls the on save function and uses sigpam to print the value.
Okay.
Boom. Okay. Um, no, that's interesting. Oh, right, because I did some other stuff there. Like, I see. Okay, and so then like if I do workflow debug, and then I can do stuff like state. I can say what's the counter value, and that just gives me the counter stripped of anything else. So you can run these wing expressions inside it. I do use this a lot in debugging. So actually, for example, we can see something I have set up here, which is I just have a scratch pad for while I'm writing the chat admin. And I have these different debug messages that I use, which are like, I can just run arbitrary like expressions.
Yeah, that's cool.
Like it is. And I've just started using that like a lot recently because it's nice.
Okay.
Yeah. Oh,
I
let's
can see
delete
how
that's
that would
actually
be really helpful. Like in the only attempt I've made at writing a Gall app, I kind of just had to like fumble through trying to determine if the different items in the state map that I had were the way that I thought that they were. You know, it's like I think it has the right
yes.
value. Let's hope.
So so we'll keep coming back to this a lot through the lessons and using debug to explore various parts of the state, but it's really useful, and that definitely like drastically increases speed. Also, the other nice thing about this is we can do things like actually this thing is wrong here. Like here I say from the state, just get me this particular thing in this chat cache map. And that could be if that map is huge and has tons of values and I don't want to print them all out, I can just get one particular value.
This is
or
also a
one
better
particular
way
fundamental.
of doing it than having like an on poke arm that handles a bunch of different nouns.
Yes. No, no, no. I mean, you're laughing, but I'm trying to look for an example. Let me see if I actually I think I mostly got rid of that. What is the thing? Let's see if I have that in life cycle still. Nope, delete. I actually went through and like switched everything to debug because until about a month ago, I actually had all the tutorial just poking lots of nouns. And this is way better.
So we can explain that. Like you can poke an application through the dojo and give it its default item if you give it a noun, which is just any kind of atom or cell afterwards. You can then have a handling case for that. That yeah, like that. So what's that
Like
from?
this right here. This is from an upcoming lesson where I haven't done this
Oh,
yet because
okay.
I was because this lesson does just demonstrate pokes. So I'll at least show people how to like, do this to themselves. Um, but basically, yeah, this one basically says, okay, if I have a noun coming in, unpack it and then start checking various things about it, and then doing actions. Or you could have it like take an action and then do various things. So yeah, you can definitely poke it, which basically poking is almost like calling your agent as if it's a function in order to like get some value back or to get some action, right?
Mhm.
And you definitely could do that to explore your state. It's just that like debug just implements all of that behavior, so it's nice to know how to do it yourself, and we'll do that. But for this exact use case of figuring out what my state is and exploring it, you definitely want to be using debug as the main thing in your workflow.
That's awesome.
And I should, well, yeah, I've actually, I can kind of do that as a supplementary thing if people have more questions in chat. Okay, Tinnis asked what vase type is, so let me go back to that. But just to finish this, what I'm gonna do is you can actually find it's in the gen. I think it's in here. Yes, in debug in the okay, so it's in like gen slash debug.hoon is list of ways to query debug. So for example, you can say stuff like app debug bool, which we'll look at later, the entire state with less debug, specific things in your state and stuff. Well, those are the main ones that I use. You can also check various things in your subscriptions. Okay. So tennis, can I briefly explain what a vase type is? Yes. What a vase? So a vase is a really specific thing. It's what you get when you take an arbitrary piece of data, like timluc-3, and run Zapgar on it. Okay, that's what it is. What it is it puts some annotation at the front about what's inside, and then inside it puts the actual data inside the queue element. Um, yeah, that works. So I could get it with the queue. Um, and then the reason they're used is because it lets you throw dynamic data around. And the reason we need dynamic data and a way to handle that is that if we look at our definition of, for example, like on load, um, it has to like Gall has to know at the time what types of things these function like each of these arms expect. And so on watch expects like a path, on leave expects a path, on init needs to produce a certain type of thing, and so on and so on. Um, and the problem is we don't know all the different types of value that people could want to throw into, on load or on poke. And so what you do for on load is you say, okay, I'm going to accept a vase, this dynamic data, and then it's up to the writer of this to get the handling of that vase right. And what get the handling of that vase right means in practice is something like, um, look, I know that my state is being generated, given to onload because it's being created by onsave with the Zapgar state. So I know that because my state is of type like, version state, that I can then yank it out using version state. So the key thing about a vase is, I'm just trying to think of like
Is it
the
like
easiest way.
it's simply a way of providing sort of like a cast and the data at the same time when those things are unknown in advance?
Yes, although you're almost never depending on the like cast at the front of it. You're almost always using some either a mark that's passed along with it, in the
Okay.
case of on poke, or in on load, you're leveraging the fact that you wrote the program, so you know what kinds of state you can have. I'll show you an example of that. So I just decided to define my V, this face V, to be timluc,
Hmm.
the tape timluc, and I should be able then to run zapgal, which lets you say a cast to apply to the data inside the vase. Yep.
Okay.
So the first thing here is a mold, and the second is my vase. If I print out the vase, it's like looks like this. And what Zapgal does is it just goes ahead and applies that tape to the thing in the Q face.
Okay.
Okay. So in the case of like this, like in this group store thing, they're able to, because they know that their state must be one of these like, of type version state, they can just use that as the mold.
Oh, okay.
Okay, so essentially they don't need a mark to be passed into onload because they're the one writing it, so they know what it is.
Yeah.
And then in onpoke, you can have arbitrary data coming in, but because it's marked, you can use that mark to like figure out what mold it should do. And
What
we'll go
is
over
the
that. We'll go over that
value?
later.
What is the value then of keeping the type in the vase?
Yes, that's the right question. I actually don't know the answer, and we should post that in chat with Palfun or whoever and ask because I actually don't know what the value of it is. It seems to never get used.
I'll accept that answer. All right.
Yeah, actually, just make a note or even just like
Yeah.
type it there because that should happen. Like it's a question that like periodically bugs me and I just never do anything about. By the way, you don't have to cast it just to a tape. You can use it to anything that it nests under. So I could yank it out as a noun, although that's not super helpful, right? But this is like each of those letters and the null terminator of the tape.
I gotcha.
I mean, you've seen this a lot, so
Yeah.
pretty basic clean stuff. Tennis, if that makes sense, just say, or if it doesn't, rate it there. I'll move on. If it doesn't make sense, I'll come back to that. Okay, so let's quickly talk about the rest of our workflow options and shifts as we move this towards kind of the end. Our main workflow options are so our editing process and install process in Gall will always be the same. Um, but we do want to have some ways of managing our source code, etc. So you have a few different workflows. You could edit the files directly in your mounted peer, which I think is what people do a lot when they're making Hoon generators.
Hmm. Hmm.
The problem there is that it makes it a lot harder to do. Like if you have a more substantial app, it makes it harder to do source control.
And the RM, like you're saying in the top line there,
Yeah,
screwing
that
it
that
up.
will also screw things. Yeah,
100% done that.
interestingly,
So, yeah.
yeah, I do have like a workflow, like a really like not recommended one that I was doing even while I was making this lesson, which is like I have my text editor open inside, like directly in the peer, and then I delete it, but the file's still open, so I just save it again and it writes it in there.
That's
But like,
brave.
I mean, I had another version of it over to the side, but yeah, it's like very YOLO.
Yeah.
So it's just like not great. If you're doing really quick one-off changes to like a file, something already in there, you can do it. It's not the end of the world. But if you're writing an actual app, what you're going to want to do is create a separate folder, edit the files there, and then copy them to your peer once you do changes. Similar to what I'm doing here, I actually can switch to another directory and show something that I actually do more in practice, which I actually have a link right here. Um, I use like a script like this. So this one is set up for my the Gall course, but
Oh.
literally all it does is it just makes sure that you have a that like command line argument with the $1. It's dollar because we're in Bash now. It's no longer bucks.
Yeah.
Um, and and then you like if it doesn't have it, then it says like usage should be this. And then all it goes ahead and does is it just copies everything in my gen app, lib, mars. These are all directories you might be developing in for Gall apps, and it just copies them to the peer directory.
That's cool. Okay.
Yeah, so in fact, the way that looks, if I run it, let's go ahead and just like run it. So I would do like, it's in my example code, I think, /sync. Yep. So I run it like this. It says, tell me a directory. So I say urbit zod home. And pure directory always means like with home on top of it.
Mm-hmm.
So I do that, and it just goes ahead. It's going to copy all of those. And now when I commit, we're going to see like a bunch more files come in like that.
Nice. That's a really
Okay.
good workflow. I like that.
Yeah, I'm going to do a little exercise at the end related to this, but that's like by far my most common workflow. Sometimes what I'll do is I modify it slightly. So if I have an app like Backy or something, I'll just put like an install.sh script like here that pretty much does the same thing. I just take out directories that I'm not using for that app. But it's other than that, it's exactly the same script.
Nice.
Okay, so your mileage may vary. Someone again, you could also write like kind of a more watch script for those things for the Slate to do the same thing, but that's one way to do it. That's definitely, in my opinion, better than the alternative of just editing directly in the peer. And then when we get to landscape apps, create landscape app and some of those similar tools, they have some like auto watch things to copy the JavaScript and Hoon files over in a similar way. And I probably could get everything set up to use their exact tool to do it for my Hoon files. I just haven't bothered. Okay. Faster fake ship startup. We talked about that. Here's the exact instructions for how to make your backup Zod directory, and then keep using it, with RM, etc. Multiple ships. This is important to know. Have you tried making like multiple ships before that like talk to each other?
I haven't.
Okay, so it's not hard. So we're in Zod right now.
Yeah.
Crap. The only thing is I don't have. Way to go. Good job.
You
I missed.
deleted
Let me
your.
see if I deleted all my other ones. Oh wait, because I wasn't using them. So what you would do? Let's see if this works. Yeah, now it's downloading pill and all that. And now it's saying mine. Okay, we're gonna stop this process.
What about that fake Bactyl? Is that one?
It won't work because it's an L ship, and those
Oh,
can't
okay.
like talk to anything. You know what? I'm just gonna make this really easy. Like, and I should add a little thing to it. You just do this. Then in another terminal, you do /urbit f bus. They can now see each other. And while currently, if I write like hi bus, I won't get anything back. If it was up on my local network, like on the same machine, it would give me something back.
Got it.
Okay, so it'll treat it as if it's like a real identity. We're going to use this a lot in the poke and watch lesson because obviously it's like
Sure.
more interesting to do subscriptions and pokes if it's going between different ships. Finally, we have L ships. I will show like how to make one of those. So Bactyl is like a real Urbit ship that's running elsewhere on my thing. I've copied. So here's the steps. You want to be really careful with them because if I ran Urb like this on my regular Bactyl, which is like in Urbit, like this, now it would be isolated from the network. The problem is it'll be doing changes inside my real Bactyl, and it'll like apply those events once I go back up.
Yeah. And then
Okay,
you'd be
so I
boned.
could do weird, and yeah, and if I make a mistake, then that mistake will be in there.
Okay.
So the line that I almost could hit enter for right here, we will not hit enter for because it is a bad line. So instead, what we do is, so we would do something like /urbit l fake Bactyl, which is the one I've copied over. And now notice that we're here and I'm in Bactyl Timzod. But
Okay.
it's like this version of it, and I might even. I wonder if I have anything in there. It's kind of like interesting. Probably not. I think I deleted it. Oh no, it does have it. Yeah. So I actually can go ahead and I have some previous app state saved in there.
Nice.
That I just queried for the key thing to note here is that I already had an app installed and I just pinged it with debug and asked for a part of its state and it like has that.
And that's
Okay, it has
from copying the pure from the existing instance of Bactyl.
yes,
Yeah. Okay.
exactly. And so I have like and if I looked at even more interesting, if I looked at like its actually I wonder about that. If I don't know what is it okay? So it says it's on localhost 80. I might even be able to test stuff. I just haven't tried this, like its landscape. Yeah, I can test its landscape too.
That's
And in
awesome.
fact, it even knows about the chats that are in there. So that's all really useful if you want to like kind of have real data to work with and real stuff to test. And I know Talon people use L ships like all the time for this exact reason.
Okay.
Because then you don't have to seed your ship with data as you would with a fake Zod. The annoying thing about them, and I need to double check whether this is the case. So we wanted to like, I think we needed to check. What was the thing we wanted to check? I
The
just wanted to check
type and the vase value, or why the
in
type
the
is at the top.
vase,
Yep.
like what's the point? And then other thing to check is can L ships talk to others? In my experiments, the answer is no. So for now, the answer is no, which is I have Zod like running up here, but I cannot high Zod. It doesn't give me anything back.
I wonder if it could talk
Okay.
to other L ships, but that wouldn't make sense because they'd have conflicting states potentially.
Yeah, yeah, exactly. Yeah, I don't know. I don't think they can. So, and I think if I recall correctly, that was one of the sources of errors in the groups refactor is they were doing a lot of L ship testing, and like they weren't able to get them like have them talking to each other
That makes sense.
because they wanted the win of the like existing data and making sure that would migrate, but it was hard to find ways to test it like in a real context.
Yep.
So they should have done real chats and then just like gone for the gold with like just developing on live
Just
chips.
be brave.
Okay, yeah. Which editor to use? Any text editor is fine for Hoon. What do you find people using mostly? I just like Emacs. I know all the commands, but really anything is fine.
I am using
To
VS
work with.
Code in the lessons that I show on screen most of the time. I started out using Vim because that was
Mm-hmm.
the only text editor that I was like really aware of, but the workflow for VS Code is like way better for me. So
Oh,
yeah.
really interesting.
Well,
Yeah,
I
because
mean,
I
it's
started
just
with
because
VS
it
Code when I went.
shows like I was running two terminal windows where I had Vim open on one terminal window and then like the Dojo on the other one, and having them both in one windowed instance with the ability to save files like pretty easily and open different
Oh,
folders,
right.
that kind of stuff. The additional values of VS Code is better for me.
Okay. Yeah. So point being, you can use basically anything, and it works pretty well. Mine, I'm just like so comfortable as used to like kind of flipping between screens that I use that as my main mode. I obviously could be, running like a terminal to copy files inside Emacs or something, but I'm like super comfortable with this mode. Okay. Our approach that we're going to use approach two throughout these lessons, which is creating a separate folder, editing the files, and doing it. Yeah, Tinus Vim is great. Um, and like especially in combination, you can combine it with terminals. Um,
That's right.
Rizrook is VS Code is better for you because you're a noob.
That's correct.
Okay. Um, so that's our approach is to copy the files as we edit them. Workflow summary for Gall is generally going to be a fake Zod running, also could be an L ship. Um, Mount it, get your VI file with the Gall code into like the app directory or any other directories, as we'll see them as commit, and then run start your app name. And then every time you edit, make sure your new file ends in app, or we'll see some other relevant directories later, and that you commit. Any questions before I go on to like this one's gonna have some like pretty basic exercises just to start getting ready for our chat admin app.
No, I'm cool.
Yeah, I think one nice thing about I think you've seen about Gall so far, even in as we're exploring the actual code, there's not really any brain teasers. Everything is like very systems oriented and just putting stuff together and knowing what does what and how it works. And once you learn it once, it generally fits into pretty clean models. But it doesn't have the brain teaser aspect of a lot of like kind of learning Hoon or figuring out how to do that stuff. So in some ways, it's like a lot more. I have a lot more fun just like sitting down for a couple hours and just messing around with stuff. Have like a decent workflow. It's like pretty relaxing, to be honest. I really enjoy it, especially with Hoon's like type validation being decent-ish. Like if my thing compiles, I'm like fairly close a lot of the time.
I think the great thing
So
for me is having somebody walk me through the syntactical weird things that are happening. So like the default agent and how that's being called, or
Yeah.
the existence of this, or like even just how state is the head of itself, like which is state zero up there on where you have the tis bar and everything. Those things, like at first blush for me, are very confusing, and so they kind of put me off of trying to investigate further what's happening there. And I know that that's like a failure on my part, but it's great for you to
No,
walk us
it's.
through that.
I mean, I know, dude. It took me a long time to get through them all, like as well, because each of them is like really simple on its own, but literally figuring out syntactically what the dot was here,
Right.
like took me an hour at one point until I finally just because I thought it was like some useful thing to know, and it really was just reduced to like, oh no, that's the syntax for just setting the sample for all the arms of a door. Like
Yep.
it wasn't interesting. And that's a lot of this stuff. And this state pattern, it's pretty easy to grok once you get what they're doing, and it's in everything, so you just see it over and over. There's no magic. Pathos says, "Why is it important to create a separate folder outside my fake?" Yeah, Pathos. The reason is that you'll very often, for various reasons, want to just delete your fake Zod. And I actually should explain why right now. We'll get into more reasons later, but I will explain why right now. Um, you're going to want to delete your fake Zod if you somehow get it into a weird or inconsistent state. Because as we said, Gall goes ahead and registers your app. So I'll give you a concrete example for why I would want to delete my fake Zod. Let's say I decide to change counter to tape, and I haven't released this app to anyone yet, and I've just been kind of messing around. And I'm like, you know what? Like counter, that should really be a tape. Okay, let's like go here. Let's like change it to like something grammatical, and I want to do this, and this is just gonna break everything once I do it because I just changed the type without having any kind of upgrade path. Well, actually, this will work now because I'm doing it. Because I deleted my Zod and went back into it. Please work live coding.
Okay, copy again. Yeah.
Because it, yeah, exactly. Because I deleted it and went back to it, I can just go ahead and make that change. Yeah, and it does work, and I'll workflow debug, and there it has like a really cool sentence in counter now. Okay, does that make sense? So if I hadn't done that, let's say I wanted to go back to an atom now, and this is probably the best way to show it. So let's show what happens if I don't delete the fake Zod, and I go and just change this initial value back to an atom, and copy the code in, commit it. It's gonna throw a bug now, or that really should throw a bug. Oh, because it's not running on a init. Mm-hmm, mm-hmm. There's like lots of. All right, you know what? Now I'm gonna go back to a tape, and it's gonna mess up. I have to think. This is why live coding is bad. There. What? It just keeps like resetting it to 0.
It's weird.
Oh no, I know why. I know why. It's because it's using onload default. Okay. So normally you would have a function that's taking your old state and making the new state be the like whatever the old state was, and
Mm.
that would cause a nest fail. But in this case, because we just completely overwrite the old state every time, which is what onload default does, we don't have any issues. But generally speaking, I would have a function in here that's like something that sets old state to new state,
Mhm.
or sorry, I have that exactly backwards. New state to whatever the old state was, right? We just like upgrade that, and because like if we tried to like set our counter to an atom here, it would break because it doesn't nest. Okay, so Pathos, the reason that we want to do it like this is that notice that in all of this editing, even though my thing actually did work, I didn't really have to care about the fact that I was randomly deleting my fake Zod at times because I had all of the code in this other folder right here in my example code folder, which I would have like under source control. And in fact, actually, I do have Git running on it. Okay, so the main reason is that you can delete the ship if it gets inconsistent and you don't want to provide like an upgrade path and onload while you're still in development. And you can, the key one is that you can version control your code. That's a really important question and really important point. And that last one is like the big one. You don't want to just be like coding. You don't want to put your whole ship into version control. That would be crazy. And the main thing is then you want to delete it sometimes. Okay, so for exercises for this one, make a new project with one directory, like /app, and create an install script or modify the sync.sh that I put above, like right here, so that you have that ready to go and you're comfortable using it to copy files into the peer of your choice. Okay, and then make sure you can see those files once you commit them in the fake sod. And then so that's one of the first. And then the first steps for yes, exactly, Pathos. You can, if you bork your ship, you could just load the same one without the error and just completely change potentially your data structures in your app
While also
and just have
preserving,
it load them from scratch
yeah, while preserving your
while
app
also
is the,
preserving.
yeah, tough part.
Yeah, preserving your app. So it's all these things are really big. You can get a totally clean slate anytime while just preserving your
Mm.
app. So first steps for Picky then after we make this install script for everyone. Like on a real planet, make sure you have a group with at least 2 chats and a couple members, and you should be an owner and an admin of that group. Copy that ship's peer to a separate directory as fake ship or similar, and then make sure you can run it with L fake ship, or whatever you want to call it, and just make sure that that's working and it's mounted and you can do everything there. Okay. And
Yeah.
I don't anticipate any big issues, but if anyone has issues with any of this stuff, just post it in anywhere in this like Gall 101 thing, and we'll sort it out quickly. I know that's like super basic, but there's not a whole lot I can do with workflow besides just making sure everyone gets it. And in our next lesson in a couple days, again, I really could have just run this one tomorrow, but I have a lot of stuff going on right now. We're gonna look at like everything about the arms, what they do semantically, what they're expecting, how the code's organized. It's going to feel like a lot more substantial, but that's because we just had to set all of this stuff up today, and I just wanted to give people like an initial feel of what like Gall apps would feel like and some little tricks. Any
Great.
other questions?
Let me check the Twitch chat just to see if we had any in there. We did not. Okay.
Okay, good. Everyone's using Urbix. Urbit's awesome now. Okay. And this stuff, I mean, it sounds kind of basic, but like literally when I was first starting, like everything here of like what's the best way to do this, like the stuff I'm just prescribing you to do, like you will have a good time writing apps like that, relative to the alternatives. So it feels really easy, but it wasn't like completely obvious from the start.
No,
So
this
just
like this directly addresses problems that I had in developing a Gall app for the last hackathon. So like even having some experience in I'm not a coder by trade or by IQ. So like
by
having
inclination, or I
right.
don't even like what I'm doing right now. Like, what room
Right.
is this?
So so having somebody walk me through like a strong workflow is a good thing. So thanks for doing that.
Yeah, I mean, many Boffins died to get this information. So, all right, guys, if I don't see anything there, I'm gonna leave it at that. Just post any questions in the classroom or in the other chat in this group. We'll get to them. We'll get it. Anything else about the lesson in general, feel free to post, especially people who are watching later on video. And I might make some little edits to the lesson based on that. And with that, I'm going to sign off.